Assalamu alaikum students. How are you? We start the chapter 3 with exercise 3.1. In this exercise, we learn the conversion of a given number in ordinary notation into scientific notation and the given number in scientific notation into ordinary notation. We already discussed, if you recall, the concept discussed in the lecture of what is scientific notation, which is helpful in solving this exercise. So let's recall few things and discussed in that lecture. That is, the symbol used is called reference position. M is significant and N is power. Let's recall the concept. Power may be positive or negative. Reference position is placed after the first non-zero digit from left hand side, whereas power is determined by the number of digits between reference position and decimal point, and the power is positive decimal point lie on the right hand side of reference position, and power is negative when decimal point lie on the left hand side of reference position. Let's do the question number 1 of exercise 3.1, in which we are required to express each of the following number in scientific notation. We are given a number in ordinary notation 5700, and to convert it into scientific notation we use this phenomena. We recall, we put a reference position after the first non-zero digit from the left hand side. That will help us to write the significant, and that will be 5.7. As we know that the decimal point lie in such a number after the last digit, that is the original position of the decimal point, and that is the relocation of the decimal point which will give us the significant, because we know that according to the definition of scientific notation, the significant will lie between 1 and 10 or 1. So we follow that condition and the number will be between 1 and 10, that is 5.7. For this sake, we have to put the decimal point between 5 and 7. The second part of the number in scientific notation will be written in the 10 raised to power n form. So n is actually the power, which may be positive or negative, and as we know that according to the concept, power is positive if the decimal point lie on the right hand side. The decimal point as lie on the right hand side, the power will be positive in that case, and the number of digits will determine the power 1, 2, 3. So therefore we write 10 raised to power 3 for this part 1. Hence 5700 is equal to 5.7 into 10 raised to power 3. In part 2 we have 49,800,000. To convert it into scientific notation, we first mark the original position of the decimal point and place the reference position after the first non-zero digit from left hand side. Hence the significand will be 4.98 because the new acquired position of the decimal point between 4 and 9, so if we write 4.98, and the second part is written in the form 10 raised to power, so the number of digits will determine the power, that is 1, 2, 3, 4, 5, 6, 7. So we write as 4.98 into 10 raised to power 7. The idea is very simple. Again, we locate the original position of decimal point. If there is no decimal point written, the decimal point will lie after the last digit in such numbers. So we place the reference position after the first non-zero digit from left hand side, which will help us to not only to determine the significand but as well the power of the 10. So now we write the significand 9.6 into 10 raised to power. The power will be 1, 2, 3, 4, 5, 6, 7. 7 it is. As the decimal point is on the right hand side of the reference position, so therefore power is positive. So now we move to the next part, part 4. Decimal point is already located. The original position of the decimal point is between 6 and 9. We place the reference position to write the significand 4.169, and the second part 10 raised to power. The power is determined by the number of digits lying between decimal point and reference position. As decimal point lie on the right hand side, so therefore power is positive. Therefore power is positive. So number of digits are 2. So therefore we have the power as 2. Now we do the same procedure to the part 5. We place the decimal point in the last reference position between 8 and 3 to write the significand, which will be 8.3 into 10 raised to power, and power is determined by the number of digits lie between decimal point and reference position, and that is 1, 2, 3, 4, and as decimal point lie on the right hand side of the reference position, so therefore the power will be plus 4. We move to the next part, 6. In this part the decimal point lie over here, and we place a reference position after the first non-zero digit from left hand side between 6 and 4. Now we write the significand, which will be 6.43 because reference position will help us to write the decimal point, relocated position of the decimal point, which is 6.43 into the second part is in the form of 10 raised to power n, and the power n will be the number of digits lying between the reference position and decimal point, and that is 3. 1, 2, 3. But as the decimal point, original position of the decimal point is on the left hand side of the reference position, so therefore power will be negative. So we write minus 3 because 3 digit on the left hand side decimal point originally located. So now we move to the part number 7, in which we observe that again decimal point lie on the left hand side of the reference position, which is placed between 7 and 4. The significand will be 7.4 multiply 10 raised to power n, and power will be negative as decimal point originally located on the left hand side of the reference position. So therefore 1, 2, 3, 4, the power will be minus 4. Now we move to the part number 8. Again we have to deal with the same kind of problem. Decimal point lie after the last digit, and we place the reference position after the first non-zero digit from left hand side, which is 6. So hence the significand will be 6. Because in significand we do not write 0 after decimal point, so therefore we write only 6, the integral number. Now we have to write the second part consisted of 10 raised to power n, and the power n is determined by the number of digits lying between reference position and decimal point. And these are 1, 2, 3, 4, 5, 6, 7. So hence that will be 6 into 10 raised to power 7. Now we move to the part number 9. The same phenomena which we discussed in the previous parts. We place the reference position after the first non-zero digit from left hand side, which is 3, and the originally located decimal point lie over here. So we write the significand using this, placing the decimal point in place of reference position. 3.95 multiply 10 raised to power n, and n is determined by the number of digits lie between reference position and decimal point. And the number of digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. So power will be negative. Why? Because decimal point originally located on the left hand side of reference position. So therefore power will be minus 9. We move to another number which is written in the form of a fraction. So we deal with numerator and denominator separately. So 275, reference position is placed after 2, between 2 and 7, and we write significand as 2.75 into 10 raised to power, and the power is actually 1, 2, 3, 4, 5, as number of digits lie between reference position and decimal point are 5. So therefore power will be plus 5, because the decimal point lie on the right hand side of the reference position. In denominator, we write reference position after the first non-zero digit from left hand side, which is 2, and decimal point originally located is over here. Now we write the significand as 2.5 into 10 raised to power, and power is negative because the decimal point originally located is on the left hand side of the reference position, and the number of digit is 3. Therefore the power will be minus 3 in that part. And now we move to the question number 2, in which we are required to express the following numbers in ordinary notation. The numbers are written in scientific form, so therefore we have to convert them into standard ordinary notation. So for this sake, we have to actually consider that what is power. If power is negative, so we write this significand a little bit further, leaving some space, and if power is positive, we write from the equal sign. So let's begin it. As we have 6 into 10 raised to power minus 4, we write, leaving some space, the 6, the significand over here, and we place the reference position to locate the original position of decimal point. As power is negative, it means decimal point will lie on the left hand side of the reference position, 4 digits away. So 1 digit is already there. We put 3 zeros to make 4. So now we put decimal point over here, and to highlight we put 0. So hence 6 into 10 raised to power minus 4 becomes 0.0006. Now we move to the part 2. In part 2, we have power positive. So we write from the equal sign. The significand, we remove this decimal point and we write in place of that reference position 506. In place of that decimal point, we write reference position. Power 10 means that the decimal point will be located after 10 digits from the reference position on right hand side, as the power is positive. So 2 digits are already there. We put 1, 2, 3, 4, 5, 6, 7, 8 zeros, and the newly acquired decimal point position is on the last. Now we move to the part 3, and significand is 9.018. We write significand leaving some space, 9018, removing this decimal point and placing the reference position in place of it. Now we have to put the zeros by using the power. Power is negative, it means the decimal point lie on the left hand side of the reference position, 6 digit away. So 1 digit is already there, and we have to put 5 zeros, 1, 2, 3, 4, 5. And we put decimal point. Now negative power 6 will determine that the 6th digit from reference position to the left hand side. We highlight decimal by putting one more zero on the left hand side. Now we move to the part 6 in which we have to deal with the positive power. We write significand as 7, 8, 6, 5, removing this decimal point, placing the reference position to find out the original location of decimal point by the power 8, which tell us that the decimal point lie after 8 digits on the right hand side of the reference position. 3 digits are already there, 1, 2, 3, and we put 1, 2, 3, 4, 5 zeros and put, just for the understanding, a decimal point over here. And now we get the ordinary notation and we express the following given number in scientific notation into ordinary notation. I hope now you are familiar with the conversion of a given number from ordinary notation to a scientific notation and a given number in scientific notation to ordinary notation. Very well. Thank you.